An interstellar object from a distant star system, hurtling along at 210,000 kilometers per hour, is on the verge of skimming by Mars at a mere 30 million kilometers distant. Yet there's a major hitch. Earth will soon go dark on it for 6 full weeks, obscured by the sun right when this rogue comet, 3I/Atlas, reaches its nearest point. Only the Mars orbiters, loaded with every available camera and spectrometer, can serve as our sole observers for this unprecedented occurrence. It's a pioneering monitoring effort that might reshape our understanding of extraterrestrial substances. Should a single device malfunction, the opportunity closes abruptly, and the enigmas of 3I/Atlas fade into oblivion. Imagine the cosmos delivering a signal, and our response boils down to praying that Mars picks up the call. 6 weeks, that's how long the blackout lasts. Our world falls into compelled quiet as 3I/Atlas arcs behind the sun. The setup leaves no room for mercy. Telescopes and detectors across Earth get blocked, not by breakdowns, but by the basic reality of celestial positioning. The sun acts as a barrier of intense heat and interference, positioned squarely in the line of sight to the comet. Throughout all of October and into mid-November, Earth rotates on the far side of the solar system, isolated from the nearest interstellar guest we may ever encounter up close. In contrast, Mars holds a slight angular advantage, sufficient to maintain visibility of the comet. At 30 million kilometers, 3I/Atlas will zip nearer to Mars than to any other world, a span under 1/4 the Earth-Sun gap, a stellar close call in the realm of planetary journeys. From our planet's perspective, though, the trajectory stays concealed. The spectacle unfolds in an exclusive cosmic arena beyond our reach. This interruption stems not from poor scheduling or tech glitches, but from the inexorable dance of orbits around a star. That 6-week gap proves pivotal, not merely troublesome. The comet's perihelion, its peak ejections, its most luminous phases, all occur amid Earth's invisibility. All insights and data streams must originate from Mars-orbiting platforms. Miss one image from those probes, and there's no do-over. The configuration bars us entirely, compelling reliance on hardware stationed on another world. Temporarily, Mars emerges as the lone sentinel with unobstructed sight lines, the exclusive recorder of a stellar happening that eludes Earth's grasp. Mars Express and the ExoMars Trace Gas Orbiter stand poised. These aren't mere satellites. They're humanity's vigilant sensors for the coming 7 days. Each packs a custom array of tools. Mars Express employs the High-Resolution Stereo Camera, HRSC, to document the comet's evolving form and trajectory. Its Omega infrared spectrometer probes for signatures of foreign ices, as SPICM detects subtle atmospheric vapors on Mars. The ExoMars TGO contributes CASIS, a color and stereo camera, plus NOMAD, a spectrometer calibrated to detect elusive compounds amid the comet's envelope. Every tool serves a precise role. HRSC and CASIS monitor the core, watching for abrupt splits or emissions. Omega and NOMAD analyze spectra, pinpointing traces of carbon dioxide, water, and carbonyl sulfide. SPICM and NOMAD stretch detection limits, seeking traces absent in typical solar system comets. The experts steering these systems, engineers, strategists, researchers, operate in continuous rotations, fine-tuning imaging durations and viewpoints as the comet speeds by Mars. Synchronization never lets up. Observation slots are narrow. Each orbital flyby unleashes a torrent of unprocessed signals, squeezed and beamed to Earth, then scrutinized for bursts or disintegrations. Commands undergo dual verification. Scenarios get drilled repeatedly. Error tolerance is minimal, but the importance is evident. This represents the singular shot to decode the makeup of a body forged in a foreign stellar cradle. Amid it all, one truth holds firm. 3I/Atlas endangers Earth not at all. Its minimal distance, even upon reappearance in December, clocks in at 269 million kilometers, pulling away swiftly into obscurity. The figures keep shifting. Ground observatories estimate the 3I/Atlas core at 440 meters to 5.6 kilometers in diameter, a spread over an order of magnitude. The heart conceals itself under layers of debris and gas. Its actual outline smudges within a coma spanning 26,400 by 24,700 kilometers, double Earth's girth. The comet's stuff predates our Sun, locked at minus 270 degrees Celsius for eons while wandering interstellar voids. As it nears Mars now, it stirs dramatically. Outbursts ignited at 6.4 Australian dollars from the Sun, where usual comets stay dormant. Within 3I/Atlas, exotic ices surpassing water likely fuel sprays and flares in frigid depths. Instruments on the James Webb Space Telescope uncover a turbulent mix: carbon dioxide, water, carbon monoxide, carbonyl sulfide. The proportions challenge familiar solar system norms. Terrestrial polarimetry uncovers further riddles. The coma exhibits rare intense negative polarization at low phase angles, akin to the murkiest, frostiest bodies past Neptune. Every reading suggests something groundbreaking. Unfamiliar chemical makeup and structural peculiarities surround the comet. The spacecraft circling Mars are working to unravel these mysteries, determining the core's dimensions, charting the composition of its volatile substances, and monitoring any potential breakup. Each measurement reinforces the idea that 3I/Atlas stands out as an exceptional case even among other interstellar wanderers. A set of 5 key inquiries guides all efforts. Does 3I/Atlas exhibit a unique chemical profile compared to comets native to our solar system? How does its material endure after eons in the void between stars? Which gases burst forth as it warms? Is it possible to trace its birthplace? Will it hold together at perihelion, or will it shatter? These challenges go beyond mere curiosity. They dictate the strategy for every measurement and the ranking of incoming information. Dr. Ariel Grakowski, collaborating with the Unistellar Network, has rallied a worldwide collection of amateur telescopes. By combining light curves captured from homes and urban vantage points, they enable ongoing surveillance of the comet's behavior. Her group's findings integrate with the Allen Telescope Array's records, which have accumulated more than 21 terabytes of radio and visual observations. What were once seen as unreliable amateur sightings now serve to detect abrupt flares or faint variations in the surrounding dust cloud's luminosity. At the same time, the discussion intensifies. Avi Loeb from Harvard highlights the improbable statistics. In less than 10 years, 3 such extraterrestrial bodies have appeared, with this one now gliding a mere 30 million kilometers from Mars amid Earth's communication blackout. He suggests the probability falls below 1 in 1,000. Established experts respond by noting enhanced detection methods and previously overlooked concentrations of these objects. The expansive carbon dioxide envelope, extending over 348,000 kilometers, fuels arguments on both sides, either as evidence of unusual reactions or as a typical result from long-term cryogenic storage. With the Mars observation period shrinking, resources from grassroots efforts to cutting-edge spectral analysis are all mobilized. The resolutions hinge on what these interconnected systems manage to record before the comet fades from view. October 29th marks the moment when 3I/Atlas reaches perihelion, its nearest approach to the Sun at 1.36 astronomical units, slightly outside Earth's path. Yet Earth stays in the dark. The Mars satellites have transmitted their final visuals, sending data bursts back to mission control as the object moves beyond grasp. The following chance arises not from a nearby world, but from farther out. ESA's JUICE mission, heading toward Jupiter, plans distant scans from November 2nd through 25th. Its sensors are optimized for subtle signals. However, by then, the comet will have passed Mars, evolving in form and composition as it curves around the Sun. The drawback lies in JUICE's remoteness and constrained data transmission, offering no immediate insights. Unprocessed information will arrive gradually across several months, with preliminary findings anticipated in February. Come December, terrestrial observatories restore their direct view. But 3I/Atlas will sit at 269 million kilometers, dimmer and pulling away rapidly. March 16, 2026, signals the final chapter, a gravitational assist by Jupiter, followed by eternal departure. Time presses relentlessly. Each deadline seals off an access point, forcing researchers to await results that might transform our understanding or simply deepen the enigmas. 3 possible paths emerge from the data currently en route. Optimistically, the Mars craft and JUICE yield a full chemical profile. All elements cataloged, every gas inventoried. Analysts uncover proportions and substances that upend theories of comet origins, exposing remnants from a stellar system long extinct before our planet formed. The dust envelope, spanning 26,400 by 24,700 kilometers, transforms into a testbed for extraterrestrial processes. Should the emission spectra reveal utterly novel traits, scientific literature updates instantly. A more probable scenario unfolds without drama, yet holds equal value. Incomplete readings, hampered by range and interference, nonetheless prove that 3I/Atlas defies norms. The prevalence of carbon dioxide, the premature activation, the absence of distinct cyanide or nickel indicators, these traits suggest formation under alien conditions. Experts will argue over gaps and interpretations, but the core insight endures. Comets from beyond are more than escaped locals. Each discovery bolsters this view, even as uncertainties grow. The dire possibility brings quiet failure. Detectors snag only whispers of evidence. The core stays obscured, and the chance evaporates without clarity. The object's immense halo and the operation's scale then underscore the scarcity and transience of such encounters. The next arrival might wait decades. For scientists worldwide, the takeaway rings true. Every scan and partnership counts. This marked the initial multi-spacecraft pursuit of an interstellar intruder, a practice run for future arrivals. On October 3, 2025, interstellar comet 3I/Atlas will streak within 30 million kilometers of Mars, nearer than any prior cosmic outsider in recorded history. While Earth faces a 6-week silence, only ESA and NASA probes orbiting the red planet can document the passage using instruments designed for alien terrains. Researchers recognize that 3I/Atlas hurtles along at 2 traveling at 10,000 kilometers per hour. It transports substances kept at -270 degrees Celsius using a unique blend that features carbon dioxide, water, and carbonyl sulfide, a combination unprecedented in any observed comet. Nevertheless, its exact dimensions, inner composition, and exact provenance continue to elude us. The observations gathered from October through November 2025 won't arrive back on Earth for several months, and certain mysteries might stay unresolved indefinitely. Without doubt, this pioneering joint effort involving multiple spacecraft represents a pivotal advancement in exploring objects from beyond our solar system. After 3I/Atlas departs the solar system on March 16, 2026, those enigmas could vanish for good.